Hi everyone. Last time when I talked about domain restriction, the examples that I give never really demonstrates this particular scenario. So, um, in this video, I will try to cover this scenario, this particular picture over here, and then I will also give one other example where you can explicitly see that you need domain restriction to find the range of the composite function. So let's look at the first example that I have. So given that your f of x is the exponential function e to the power of x, and g of x is x plus 1 squared. So in this particular example, I don't really give you the domain and the range. So you can sort of like freely play around the domain and the range in such a way that you want to define the composite functions of gf and fg. So let's say the question asks you to just define the composite function g of f and f of g. So if you want to do this, basically you can write down the domain and the range for each of the function, and then you just identify, let's say for example, the largest domain of one of the function, so that this particular composite function actually satisfies this picture. So let's look at f of x first. So f of x is exponential function. We all know that the domain would be the set of all real numbers, and the range would be just y greater than 0. So this is the largest possible domain and its corresponding range for f of x. So now let's look at g of x. G of x is x plus 1 squared. So if you study the domain of g of x, domain of g, it will be given by all real number as usual. So the range of g would be greater or equal to 0. In this case, it's a quadratic equation. So now let's look at the first composite function, which is g of f. So if you do this, you can write something like this to get e to the power of x plus 1 squared. So now let's look at the domain of this particular composite function. So because you do f first and then you do g, so it means that the range of f has to be at least the subset of the domain of g. So in this case, this is true because the range of f is y has to be greater than 0, and the domain of g is the set of all r. So in this particular case, if you draw the diagram, the set diagram for example, so I will just draw it here. So you composite f first, then you composite g. And the range of f is a smaller subset because the domain of g is all real numbers and the range of f is positive numbers. So this is true. But because you have a smaller domain for G in this case, oops, sorry. I think it's better I don't draw the diagram. Okay, it's better I don't draw the line. But you can see that because you are mapping it to a smaller subset, so your G actually only functions on this particular smaller domain, the one shaded in black. So it means that when you go to the other side, the range of G of f, it will become smaller. So it will not become y greater or equal to 0. So let's go back to the domain of G of f. Basically, this will be equals to the domain of f, which is greater or equals to r. So now let's look at the range of GF. Because you limit the domain of G in this case to positive numbers, so it means that the range, so you just look at this particular graph. So the range of f is as if you are trying to find the range of G given this particular set of domain. So then it means that you can substitute x equals to 0 inside. You find that the smallest number that you can get is 1. So it means that the range of GF is y greater than 1. There's no equal sign because over here there's no equal sign. So that's how you can find the range of GF using this particular method. And you can see that the range of G is also smaller than what is originally being defined. It's not the whole range of G. It's a smaller subset. So let's look at, in this case, f of G. So this will be the f of x plus 1 square. And when you composite function it, it becomes e to the power of x plus 1 square. So the domain, so this time you need to be careful because if you look at the range of G, the yep, it's still valid because the range of G is a subset of domain of F. So in this case, this particular composite function is still being defined, and the domain will become this. In this case, there's no need for you to restrict your domain, but you need to be careful when you define the range because the how should I put it? The range of the first function is a smaller subset of the domain of another function, which is why you need to be careful to write down the range in this particular case. So in this f of g, the domain is still defined. It is still, of f of g. So the domain is still defined, is still following the domain of G. So now let's look at the range. So the situation is similar as above. It's just that now you are changing from f being the first function to g being the first function. So what happens is your second function, sorry, this is not gf, this is fg. So it is as if you are defining your fx, which is your second function, given this particular domain, which is the range of g. So what is the smallest value in this case? The smallest value is when x equals to 0. So your f0 is 1. And because there is this equal sign, which means that your range will be greater or equals to 1. So that's how you find the domain and the range in this case. So whenever you see something that is defined as in this particular figure, whereby your range of the first function is not equal, but in this case is a subset, then you need to be slightly careful when you define the range. So usually this does not really happen, at least in the exam sense. Usually it does not happen, but it can be. So perhaps I should update the notes a little bit to cover for such cases. So in this case, the first point is still valid if specifically the example that I gave is happening. The second case is still valid. The third case, you need to be slightly careful if the first line over here is a subset, because then you need to be defining your range of G slightly more carefully based on the range of F. So really, I shouldn't put the subset, but equals. If the range of F equals to the domain of G, then all these 3 points are valid. But if let's say the range of F is a subset of domain of G, then you need to define your range of G based on the range of F, and that will become the range of GF. So meaning that you need to be slightly careful when this particular case happens. The second example that I would like to show is this example. So given that fx is x plus 2, x minus 1, so we know for sure x cannot be equals to 1, and gx is x minus 2 divided by x plus 1. We know for sure x cannot be minus 1. Find the... Wait, what did I ask just now? Define the composite functions. So it will be fg and gf. So let's look at the first one as usual. Okay, the domain of f would be the set of all real numbers, but you exclude one point, which is not -1 but 1, which is 1. So the range of f requires you to find the horizontal asymptote. So since I have not really covered how to find horizontal asymptotes at the moment, let's just let me just give you the so-called answer. Is actually 1. So that will be your range of f. Of course, you can use the method that I show you, the first or the second method, but I don't really want to go through this right now. So let's just say I know the vertical asymptote is x equals to 1. I also know that the horizontal asymptote is y equals to 1. So for G, the domain of G would be the set of all R excluding -1. Whereas the range of G would be, again, I will just give you the horizontal asymptote, y equals to 1. So let's begin with f of G. So if you look at f of G, it will be f of x minus 2 divided by x plus 1. So this is a slightly more complicated process. So this will be x minus 2 divided by x plus 1 plus 2 divided by the whole thing, x minus 2 divided by x plus 1 minus 1. So let's expand it. So I will multiply 2 with x plus 1, and then at the bottom I will do the same thing. So the x plus 1 term will get cancelled off. So on top you would get 3x minus 2 plus 2 get cancelled off. And then at the bottom, you would get minus 2 minus 1 minus 3. So in the end, you will get minus x. So this is kind of bizarre because initially you have some domain that you need to avoid some of the points. So how do you find your range in this case? So let's look at the domain of fg first. So this is also one example whereby you cannot simply guess your domain and range based on the composite function, because if you look at the composite function, at the very end you get minus x. So it is not true to what would be the domain and the range for f of g. So in this case, for domain of f of g, you know for sure that this is coming from the domain of g. That's why this will be x inside the real number excluding -1. So domain of f of g, usually there's no problem. You just follow the domain of g in this case. What is slightly problematic is the range of fg. You cannot write Why to be in the set of all real numbers? Because if you do that, so if you following this particular n function in the end, and you just write this, this is actually not correct because there are some points that you need to avoid. So in this particular example, because the range of G is exactly the same as the domain of F, so in this case, we know for sure that the range of Fg is equals to the range of F, which is this. So remember, when the range of G is the range of the first function is equals to the domain of the second function, you can just follow the range of the second function. So you need to be careful in this particular case. Now the opposite will be even worse, G of F. Let's work out the composite function first. So G of F, so F is x plus 2, x minus 1. So G will be x minus 2, so you have x plus 2, x minus 1, minus 2, divide by x plus 2, x minus 1, plus 1. So I do the same thing, x plus 2, the whole thing multiply with minus 2, minus 2x plus 2, divide by x minus 1, and then the whole thing will be x plus 2 plus x minus 1 divided by x minus 1. So same thing, x minus 1 get cancelled off. In the end, you would get minus x plus 4 divided by 2x plus 1. Okay, so now let's study the domain and the range for the first function. So the range of f is actually not a subset of domain of G, because domain of G you need to exclude minus 1. The range of f you can have minus 1 because what you need to exclude is 1. So in this case, you actually need to find what is the value of f, the x, when it is minus 1, because you need to avoid this point, so that the range of f is at least the subset or equals to the domain of G. So x plus 2, x minus 1. So x plus 2, x minus 1 equals to minus 1. So what this means is x plus 2 equals to 1 minus x. So this also means that 2x equals to minus 1, or x equals to minus 1 over 2. So this is one point that you need to avoid, so that your range of f will exclude minus 1 as well, so that the range of f is a subset of domain of G. So it means that your domain of GF would be x inside the real numbers, the set of all real numbers, but you need to exclude 2 points. one is minus half, the other one is 1, which is coming from the range of f. So then this particular, okay, so this is for domain of GF. So this particular domain will get maps to what? So the second function that you need to really be careful, g is x minus 2 divided by x plus 1. So for gx, the domain that you really have is this. So we all see that f of minus 2 equals to minus 1. So definitely you can avoid minus 1. The second point is 1. So this comes from f minus 1 over 2. The second point here comes from f of x, the horizontal asymptotes. So then you need to be careful as well when you define your range. Because if you are just having this particular domain, then you know that the range of G is just Y in the subset of R excluding 1. But this time, you have another point here. So you need to substitute G of 1 inside. Which is minus 1 over 2. So this is the second point that because of f of x, you need to avoid. So remember that this is the case whereby your range of the first function is a subset of the domain of the second function. That's why you always need to work out the range of the proper range after you getting a smaller subset due to the range, due to this particular situation. So you work out for this particular point, you actually need to avoid minus 1 over 2 as well. So it means that the range of GF is minus 1 over 2. So you need to avoid minus 1 over 2 because you already excluded the point 1 from f of x. And then the second point that you need to exclude x where y equals to 1, that is your horizontal asymptotes from g of x. So that's how you find the domain and the range for g of f in this case. So that's the whole thing about domain restriction. Basically, you try to define specifically how that composite function will be getting defined. Okay, that's all for this video. Thank you.